just switched on the recording. And so we're at example 25. And right now we're at the point where we talk about what tangent and gradient. And tangent and normal to a curve. And a few things we need to remember, that the gradient of a curve at a point is equal to the gradient of the tangent to the curve at that point. So at a particular point, both the curve and the tangent have the same gradient. Now, since the normal is at right angles to the tangent, and the product of the gradient of perpendicular lines is -1, that is from coordinate geometry, if I invert the gradient of the tangent and change its sign, I'm going to get the gradient of the normal. All right, so I'll say that again. The gradient of a curve at a point is equal to the gradient of the tangent to the curve at that point. Now, the normal is at right angles to the tangent. The normal is at right angles to the tangent. And the product of the gradients of perpendicular line is -1. So if I invert the gradient of the tangent and change its sign, I will get the gradient of the normal. Example 25. I think what I've decided in terms of progress from now on is that for the examples, I will do one, then you will do one. I think by doing that, we might move a little bit faster. But in any class, in any math class, the students must be given an opportunity to practice doing what is being taught as well. So whatever you do, I will always do it. I will always do it to let you know if what you did is correct. But what I'll do from now on going forward is I will do a question and then you will do a question. So let's have a look at example 25. Example 25 says, find the gradient of the tangent to the curve y is equal to x plus 2 multiplied by ln x at the point where x is equal to 1. All right, so the gradient of the curve is equal to the gradient of the tangent. So let us find the gradient function for the curve. The gradient function for the curve is dy by dx. So I have y is equal to x plus 2 ln x. Now, so I'm going to differentiate. This is a product differentiation. This is a product differentiation. I am multiplying two functions of x. So I'm going to have to use the product rule. So dy by dx would be, I'm going to leave the first and then differentiate the second. The first is x plus 2, so it's x plus 2 multiplied by the differential of the second. When I differentiate ln x, I get 1 over x plus differentiate the first. When the first is x plus 2, when I differentiate that, I get 1 and leave the second. So that's multiplied by the second, which is ln x. So what I just did is I just applied what? I just applied the product rule. Essentially, it is leave the first, differentiate the second, plus differentiate the first, leave the second, and I've done that. So what I have is this is x plus 2 over x plus ln x. Then I'm going to say when x is equal to 1, dy by dx would be equal to 1 plus 2 over 1 plus ln 1. ln 1, what that is the log to the base e of 1. And essentially the log to any base of 1 is 0. The log to any base of 1 is 0. So the answer here would be equal to 3 over 1 plus 0. The answer here would be equal to 3. So therefore, gradient of tangent when x is equal to 1, dy by dx, which is equal to m, is equal to 3. All right. So I just did example 25. If you are writing it down, write it down quickly. Well, I think we've already decided that we're not going to write down stuff. So note it. Then I want you to do example 26. Note it, and then I want you to do example 26. All right, so this says find the gradient of the normal to the curve. So be careful also, this did not say tangent, it said what? Normal. So if we're going to find the gradient of the normal, we have to first find the gradient of the curve, which is equal to the gradient of the tangent. So y is equal to ln x plus 2 over x minus 1. Now I'm going to use my law of logarithms. This law, as a matter of fact, that if you have ln, let us say, well, log, I'm going to show you which law of logarithm I'm going to use. Log of a minus the log of b is equal to the log of a divided by b. So if I'm subtracting logs and the base is the same, I can make it into one log by dividing. So I'm going to do a reverse application of this law to say that y is equal to ln x plus 2 minus ln x minus 1. So it's a reverse application of a law of logarithms. Now, what I have to differentiate now is ln. When you differentiate ln x, you're going to get 1 over ln x. So dy by dx is equal to 1 over x plus 2. And then you multiplied it by the differential of the inside function, which is still 1. This is the inside function. So if I multiply by the differential of the inside function, I'll be multiplying by 1 minus 1 over x minus 1 multiplied by the differential of the inside function, I'm multiplying by 1. So now when x is equal to 2, when x is 2, I'm going to get, this is 1 over 2 minus 1 over 2 minus 1, which is 1 over 1. So this is a half minus 1, which is minus a half. Tell me if you agree. Do you agree? Hello? Do you agree, guys?
Yes, sir.
All right. So now, so dy by dx, the gradient of the curve, when x is equal to 2, is equal to the gradient of the tangent. So the gradient of the normal would be equal to, you're going to invert the gradient and change its sign. So the gradient is going to be equal to 2. If the gradient of the tangent is minus a half, the gradient of the normal would be equal to 2. The tangent and the normal are at right angles to each other. So if they're at right angles to each other, the product of the gradients of perpendicular lines is minus 1. That means if I have the gradient of the tangent, to get the gradient of the normal, I must invert the gradient of the tangent and change its sign. So the gradient of the tangent is minus a half. So to get the gradient of the normal, I'm going to invert minus a half and get minus 2 over 1. And I'm going to change the sign from negative to positive. All right, so next, we're going to look at equation of tangent and normal.